Okay, I'm gonna start. So you have carbon 6. You're saying carbon is 4, right? 4 plus. Now you have oxygen. How many oxygen?
3.
3 of them, right? So 3 times 6. And what I said, you have a negative 2 there. If you remember anion, you have to add. So minus 2 means you have to add 2 there. Make sense? Since anion and you're supposed to add 2 because of negative 2. Okay? And this is because of your 3 oxygen, 3 times 6 valence electron. So total how much now? Somebody told me 22. You forgot to add this 2. That's why, right? So this is again we have 24 valence electron. Everybody good? Valence electron. 4 for carbon valence electron, right? Plus oxygen 6 times 3 because there are 3 of them. So this is your total valence electron. Now, whenever you have plus or minus, first thing you need to remember is to put them in a bracket like this. Whenever you see plus or minus, you have to put a bracket, large bracket, and you're going to put your charge outside like this. So since carbonate you have 2 minus, so I put the 2 minus outside. You must remember this bracket whenever you have plus or minus. Regular neutral one, you don't need it, okay? And now, so we did first step. Second step, what's the central atom? Told you the tips. Anytime you see carbon species or compound, carbon will be central. But if you want to go with the rule, least electronegative, carbon group 14, oxygen 16. Least is again carbon anyway, right? The left will be least, and as you go from left to right, more electronegative. So carbon definitely is your central now. And what we do, give one bond to each peripheral. How many peripheral atoms we have? 3 of them, oxygen, right? Oxygen 3. So you're going to give one bond to each. 1, 2, 3. If you want top or bottom, doesn't matter, okay? So we have 3 more oxygen as peripheral. Make sense? So far we done number 2 now. It's much faster than first one, right? So you give the central atom, give one bond to each peripheral. If you have 4, you're going to have 1 more there. But since we have 3 oxygen as peripheral, done. And if you want to keep track of your electron, do again. See, here you were confused, right, Diane? So yes. Keep track means you have already 1 bond to each one. Carbon also this bond consider, and this is also considered for oxygen. So that means 2 electrons are already in this both, right? So how many we just used? 6 of them. So minus 6. So we still have 18 like before, right? Like the one we did. So next, our step is to give 8 electron to each peripheral. So since each oxygen have only 2 so far, each one needs 6 electrons again. So how we do? Just give your electron in the form of a lone pair or non-bonding pair. So 1, 2, 3, 1, 2, 3, right? 1 pair, 2 pair, 3 pair, or you can count as 6. So for good, we used up all of them. See, total 18. We just did 6 times 3 is 18, right? So we just used up all. We have non-electrons. So again, this came out to be same story. All the oxygen are good, but carbon still 2, 4, 6 only. How many need? 2. You can put lone pair there. How to put? If you have extra 2 left over, you could have make it 2 lone pair here to make like a lone pair. But since we have no electron, we have the same this situation. If you run out of electron, make double or triple bond. So now since they are all same oxygen atom, anyone could be willing to make double bond, right? So either this oxygen or this or this. So let's try this one wanna give. That's fine, right? Looks good now, see? See, if we make this is good. 8. This oxygen also total 8, 8. So always try to circle it just to make sure yourself. See, this carbon is also now 2, 4, 6, 8. Looks good. However, as I said, right, why this oxygen? They all are willing to make double bond. Now let's say this oxygen wanna make, right? So you need to put, this is called resonating structure. I'm coming to a little bit. So here also, I'm just using different colors. So instead of double bond on this one, I wanna make double bond with this oxygen, right? Oops. I can do that. No, 1, 2, 3, 4, 5, 6. So instead of this oxygen, I made double bond with the bottom one, right? That's fine. See, there's still 8, 8, 8, and 8, right? Also, what else possible? Instead of this one, this is still willing, since it's the same oxygen atom, right? And then double bond can be with any one of them. So instead of that, we're gonna make double bond with this one now. 1, 2, 3, 4. I forgot 2 minus here. So 1 oxygen, 1, 2, 3, 4, 5, 6. And this is 1, 2, 3, 4. See, it is also absolutely fine. This is also acceptable. So now, see, you have, instead of 1 loose structure, you got 3 possible loose structures, right? And they are equally stable. So when you see something like this situation, these are called resonating structure. So whenever you have double bond possible, right, most of the situation, you can have more than 1 possible Lewis structure, and if it comes out like that, you can call it as resonating structure. And if you see in your paper, they said somewhere, show all resonance structure if applicable. You saw that in your handout. They did mention if you have resonating structure, show all possible, means like this. So this is what they, and also for you to remember the tips. Whenever you have double or triple bond, most of those situations you will have resonating structure. But if you have just a single bond, like in this situation, you can have only 1 possible. There is no low structure possible. But if you have something like, possibility for same reason, like they can have double or this one. So in those situations, you will get resonating structure. So the tips is to remember, if you have double and triple bonds with the same atoms, most of the case, resonating structures are possible. Okay? Okay, understood? Any question?
Yeah, so what happens to that negative 2 charge? It doesn't